I'm just going to write them down for you. But I'll give a crash course on it. Maybe. Right. Non-90-degree triangles. Just a crash course on the extra formula. Hopefully you guys can also recall these formula, right? So that you can... Mr. Manyanga.
Yes.
How are you doing, man?
I'm fine,
Good to see you. Please appear in the shop so I can use it as a thumbnail. Very good, man.
Yes.
It's becoming bigger and bigger, man. Huge and huge. What's going on here?
Right.
Yes. Read. You read it, eh?
Yeah.
How does it report?
I scale it, so 300.
300.
Yeah.
Alright, so you're not allowed to open, right? So, but you're in town.
Yeah.
You're in town. It's
Yeah.
good that you're in town. It's good that you're in town.
I'll come to your house.
Yes, please.
Yes.
Yes. You must. No, I'll give you a call.
Okay.
Yeah. Grade 8 to 12. Yeah, becoming old. I see the other day my face on one of these things. Like, I've got all these waves in my forehead. I've got a home button right here. The doctor said it's kind of a part of my intelligence. I think I'm becoming old, but I'm still fine. Still exactly the same. Is it not? So, something changed. What exactly?
You're old.
I'll take that as a compliment anyway. So what I was saying here, Mr. Bradley, let's take this triangle. This is a non-90-degree triangle. Let's suppose it's obviously, no, let it be an isosceles. Two legs are the same. Or for that matter, let me make it an equilateral triangle. Equilateral triangle, equiangular, all the sides are equal, all the angles are equal. Yes? Yes? So what is each angle equal to? Interior. 60 degrees. Where do you get it? So if each angle is equal to, all of them add up to that. So each angle obviously will be 60 degrees. Now, if I draw a perpendicular, it's going to cut this side in half, right? So suppose this was 2 units, the distance from there to there. That means that it's the same here. Then this is going to be 1 here, and that's going to be 1 there. You understand? Because of that perpendicular bisector that I dropped. Now that bisector creates 2 congruent triangles. This triangle will be superimposed on that triangle if you fold it here. I just want to bring in a few basic stuff that you know. If you look at this triangle and I produce it here, so this is 60, this is 1, this is 2, that obviously becomes 30, and that's 90 degrees. You agree? You see it so far? And that's the height. The way we know that the sine of 30 degrees is equal to a half is from this fact. The sine of 30 degrees is always equal to the opposite over the hypotenuse. Sine and cosine are co-functions. So it means that there is a very big similarity between the two, and you'll see once we come and do the functions, the graphs. Okay? For right angle triangle, the sine of 30 is equal to the cos of 60. Just look. The cosine of 60 degrees here is adjacent, which is what? Upon the hypotenuse. That means, if that is the case, if I was to give you the sine of 20 degrees, for example, in a right angle triangle, what do you need to add to 20 to get to 90? Still thinking? 70, yes? So that's going to equal to the cos of 70. And you can try it. Okay? So I can do for 45, 45. Also, the cos of 10 degrees will be equal to the sine of 80. You can check that on your calculator. They're co-functions. So the relationship between the sides really is that togetherness. You understand? We share some stuff. Alright? So I can do the one for the tangent, but I just want to focus on that. The height of this triangle is calculated the following way. When you are calculating the height of this triangle, let's work from this triangle we have here. When we calculate the height, Pythagoras can be used here. That height is going to equal to 2 squared minus 1 squared. Are you Pythagoras? 2 squared minus 1 squared is equal to 3. 2 squared is 4. 1 squared is 1. So h squared equals to 3. The height of this triangle will always equal root 3. When the measurements are increasing here, it will be with that factor. That means it will be 2 times, if it increases by 2 times root 3. That's always going to be there. If I ask you to calculate the area of this triangle, you know a half times base times height. A half times the base is 1. But if I want the whole triangle, the base will be this whole 2. You with me? So if I want the area of the triangle, if I use this one, then I must now double that answer. That means I will have to add. So I'm going to use the area of the big one. So that's a half times 2 times root 3. The area of the triangle, very interesting, also give you root 3. But I'm not saying that the area of the triangle is always going to be equal to that height. It's just like in this particular case, because I chose this 2, right? But then there's also something else that is very interesting. If I just take this part, and I want to find the area of the triangle here, it's going to be that height, which is root 3 times that, right? But what if we use the 60 degrees? How will you find the area of the triangle if you only have this angle here? And suppose, let's use the angle. So this introduces us to, I'm just not going to prove it this particular problem. If you take the 2 sides that are being flanked by this angle, this 2 and this 2, right? And I say a half times 2 times 2 times the sine, wait for it, of 60 degrees, which is going to equal to the cos of 30. By the way, looking at this right angle triangle, let's write it down. Times the sine of 60 degrees. The sine of 60 degrees, is that height upon the, is the height upon the hypotenuse. Is root 3 upon that. Are you with me? Okay. So that gives me 4 times 4, half of that is 2. That gives me 2 times, I hope you understand where the 2 comes from. Right? Root 3 upon what? 2. Are you with me? So once you calculate, you get that the area is also equals to root 3, which we have determined using the other way. You see that the area is the same. So what does it mean? When you're dealing with a non-90 degree triangle, you can calculate the area of that triangle given side, angle, side. Any triangle. If you know this side, you know this side, and you know this angle, and this angle is given to you, that is going to be B, that is going to be capital A. You have got two sides, side, angle, side. You can use this formula to calculate this area. Does that make sense to you? So I don't want to go into detail and prove to you where it comes from. I just want to bring out that you should know that there are other formulas that exist to calculate the area of triangles. So if a triangle is not 90 degrees, then you use this one. Because there are going to be now instances with the work that we are doing where you are given something and you're supposed to first perhaps find this area and that area. So this could be a semicircle and this could be a triangle which is not even, okay, obviously this two will be the same because it will be the radius, yeah? You follow? And then you need to find the area of such by taking that angle, multiplying it by the two sides, yeah, half of them, by taking the sine of this. I hope you understand. So we're going to use that formula. And then you still know how to find the angle or the area of a circle. Area of a circle is pi r squared, but since it's a semicircle, we're going to divide it by 2. So here where we have A, that's also going to be equal to A, by the way. Alright, although I will use different numbers, not numbers but letters. These two sides are exactly equal, so they will be like the radius. This is like an angle, maybe suppose that's angle theta. So if you want to find the area here, you'll be saying A squared, that is A times A, alright, times a half, times the sine of whatever that theta is. For this particular one, okay, we're going to go into that. So that is where this is coming in handy. You don't have time to drop perpendicular bisectors in order to create that. So it's a very important formula for you to know. So if you were to press on your calculator sine 30, this is just an added story, and you also press cos 60, because 30 plus 60 give you 90, the two values will be the same. The ratio, decimals. No, your calculator is in radian mode. This angle that I wrote here is in degree mode. So you need to change your calculator back to the degree mode for the what I'm explaining here. Is that fine? It's okay. It's an obvious error, but it's not sometimes obvious, right? You still have to get used to all this changing the mode from radian to degrees and so on. But please know that if I'm talking about degrees, I would be writing this was no differently, right? This would have been written as nothing but 1 over 6 pi. 30 goes into 180. I hope you understand that. Does that make sense? Right? What is the 20 degrees in radius? 1 over 9 pi. Zero 0.11111 pi. Did you get the answer? What is 20 degrees in radius?
20 degrees should be less.
Is it not 1 over 9 pi? Exactly. Is it not what I was saying? 20 over 180 and then the pi. Simplify 20 and 180. Come on, people, you should do this. Right, so this would have worked if you had here 1 over 6 pi, if you calculate the radius. And this would have worked if you had 1 over 3 pi. Because 60 degrees is 60 over 180, which is a third. You understand? Pi. Then it could work because your calculator then will be the right one. But you do get the same answer. Right, so this formula should be part of you for the stuff that you're going to do. Then there are others. I don't know if you're still writing. You must say if you're writing, right? So remember, we use that formula for side, angle, side. Side, angle, side. Okay? Remember my abbreviation? Okay. Let's bring in one more condition. There's so much that I can do, it's just I want to just do a quick recap on the work on trigonometry. If I take let's say triangle A, B, C. It's also a non-90-degree triangle. And I drop a perpendicular. Let's say this becomes P for some reason. So therefore, this is also 90 degrees on that side. The objective here is now to calculate the area, and also, no, the objective here is to find sides. This is B, so that's small letter B. This is C, small letter C. This whole thing here is small letter A. So we use the small letters to represent the what? Side. So if this distance from here to there is X, then the distance from here, from P to C, should be this whole distance minus X. Are you with me so far? You with me so far? If I take the right angle triangle A, B, P, triangle A, B, P, where this is X, this is the height, and that is C. The idea is to find the value of X. X will be calculated by saying C squared is equal to H squared plus X squared. You with me? Or even if I want to, let's say I want to find H. You understand that? Okay. But I'm going to leave it like that for now. If I take the other triangle, the other side, and I am doing it here, this one here, that is H here, P, still here, oh, C and our A is right on top there. Oh, no problem, no problem. This distance here is going to be what? This distance is what? Is the height. So I'm taking them and separating them. What is this distance? B. Right? I will come back here and I will write, let me leave it like this, I'll come back to the height, right? Because I'm going to take the two heights and I'm going to equate them. Right. So, B squared, because I'm starting with the hypotenuse, is equal to H squared plus, wait for it. Can you see that? Using the theory of Pythagoras. No sugar in the class?
No, they will drink it when they are out of the class.
Oh, okay. Okay.
It's for all of them, eh?
Oh, okay.
Yeah, they'll.
Yeah, Nathan is spent right now. He's writing 4 tests. He's sleeping. Mm-hmm. Thank you.
Alright. You can also drink me. All of you, let me not say them, then I will exclude you. All
Of course, that would be a new form of apartheid. But thank you. That's fine. Yeah.
See you on the 26th.
Oh, you guys are going? Let's focus quickly. I'm not going to cut this out. I'm going to upload it as it is. Pythagoras. The hypotenuse square equal to the sum of the squares of the two shorter legs. Am I right? There's something that one and this one has in common. But I first is the h. Do you understand what I'm saying? So I first want to multiply this out, right? Okay? Or I will be writing the h, both of them in terms of h, because they are exactly having the same h values. H here would be You agree? H will be c squared minus x squared. Right? Right?
Yes, sir.
H here will be b squared minus this. You with me? You with me? Alright? So I leave the h alone, this one goes and it's subtract now. Right, can I multiply this out? Okay. So this is going to be b squared minus, first when we do this, it's a squared minus 2ax plus x squared.
I have a question.
This is the shorter side, right? When you look for the short side, you subtract one short side from the hypotenuse.
Shouldn't it be a squared minus c squared?
Isn't it what?
A squared minus c squared.
X squared minus 6 squared. And which one is the hypotenuse?
I mean, like the way you rearrange.
Oh, yes. Oh.
It should be what?
X squared minus c squared. So
X is
what's
positive.
the
On top.
I mean, the x squared is positive.
The x squared is positive. Why?
The c is c.
If I look for that, it will be the sum of that. If I look only for this, it will be the hypotenuse, which is c squared minus x squared.
And the way you rearrange.
Should I start the rearrangement again? Because you got confused here. If you take this over, it becomes a minus. The h will now be there. But same thing? Same thing? Are you confused or should I start over there? You're fine? You're confused. Okay. They are asking me about the h squared. So h squared equals to, taking this over, c squared minus x squared. Then I just wrote the h squared on this side. But I will leave it like that, no problem. Okay? If you're happy. So bottom line is I'm looking for h squared. And I'm also looking for what h squared will be there. And I'll take those two h squares because it's the same height of the same triangle, right? The height here. And then I'm going to compare. I'm going to equate them. Are you with me? Right. So you will still find how I get to this. You also find how I subtracted this from there. You're not confused with this h squared? Good. Now, you also now know that this is going to change the signs. So you're going to be left here with h squared equals to b squared minus a squared plus 2ax minus x squared. Are you with me? You are with me? Now, let's then compare our h squares together. So it's going to be b squared minus a squared plus 2ax minus x squared should equal to c squared minus x squared. The idea here is to find any, I probably want to find a squared. You follow what I'm saying? Okay? So if all I want to find b squared, what will be the side? I want to find the sides. Yeah? Or if I want to find, let me say I want to find what is a squared because we use that. No. Or should I find b squared? That means I want to find what is that side. You understand? So b squared will equal to, all of that stuff goes on the other side now. Okay? It will equal to a squared plus c squared. This one changes. This one remains. This one changes. Are you with me? It becomes minus 2ax plus x squared minus x squared. What am I going to be left with? Okay, I'm going to be left with b squared equals to a squared plus c squared minus 2ax. Are you with me? But we are not done. Now I want to do something else. I want to come back to this x, what it represents. How will I find the x here in this right angle triangle? I don't want to use that one because that one is with the a with it, no? Right, because I want to take out this x and replace it here with whatever it will be. So how would you find x in this right angle triangle? I want you to find the distance. The distance in a right angle triangle, you're supposed to use your ratios. Right. You want to find this. So to find this, it must be the cosine divided by the hypotenuse. Do you understand me?
Yes.
In a right angle triangle, if you are looking for, I'm talking about this particular angle. I have an angle here, right? Angle B. This angle B. Angle B, let's call it theta, but I'm going to call it angle B. Is that fine?
Yes.
Good. Angle B is equal to, let's say, the cos of angle B is equal to the x value over what? C. I want to make x the substitute formula so that I can take that x and substitute it here. Do you understand? To complete my formula for the cosine rule. When you want to find that, you will cross multiply. So x would be c times the cos of what? B. See that? B. Cos of B. So I'm going to take this value here and I'm going to replace it here. Are you with me? Good. So what do I have? I have b squared equals to a squared plus c squared minus 2ax. But now I said, what is a? What is x, I mean? C cos b. This is giving me a complete formula. B squared equals to a squared plus c squared minus 2ac times the cosine of b. This is the cosine rule. What does it mean? If you have any triangle, A, B, C, capital letter C, capital letter B, capital letter A. If you want to find that side, so when do we use the cosine rule? We use it when we have side, side, side. When we are given a triangle with all the sides. Does that make sense? We can find the missing angle or the missing side by using this. And here's the thing. When you have side, 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 you can find angle. Sorry. Side, 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 you find angle. And the way you find angle, we're going to make cos b the substitute of the formula. You understand? Also, we can find this when we are looking for a third side, but then we must be given an angle, right? That is being flanked by sides. So that means if I have an angle here, and I know what these two are, I can find this missing one here. Because to find that missing one, you have to take the cosine of that particular angle. So this formula, the b squared, the formula that I'm going to write now. So b squared is equal to that. So a squared will equal to b squared plus c squared minus 2bc times the cos of what? A. Always like that. C squared equals to a squared plus b squared minus 2ab, always, times the cos of what? C. This is the cosine rule. This is when we use this particular scenario, when we want to find the side. So remember, after you do that, you still have to find the square root. You understand? Because you want to isolate the C, or the B, or the A. Is it not so? Once you punch in your values here, you must still go and take the square root in order to find that side. When you want to find an angle, you must have a triangle where all the sides are given. Then you can find the angle, the cosine. Use the cosine. That means we take our formula, this formula, and we make cos A or cos B or cos C, the subject of the formula. That we can quickly do. But you get the concept here of how we arrive at this. So when you have got three sides,
So
you can find an angle.
you're given two sides.
When you give it a side and an angle and a side, you can use the cosine rule. You understand? So this is used in this scenario. This would be used in a scenario I want to write down. So that scenario is,
I need an angle.
I hope that you get this, right? You can always check. And these things are also in your books, right? So if I take the cosine rule, a squared equals to b squared plus c squared minus 2bc times the cos of a. The objective here is to make cos a the subject of the formula. Are you with me? Right. This is what I'm going to do. This whole term is negative. There are three terms here. I don't like that term to be on the negative side. So I'm going to take that whole term and I'm going to put it to the right, to the left side. Do you understand me? So I'm going to have something like this. 2bc cos a. But there was already a square. Are you with me so far? So objective is to make this the subject of the formula. So I'm going to subtract that a square first. 2bc cos a equals to b squared plus c squared minus a squared. One of the things you should remember when you're writing this formula down, whatever the cos a is, what you're subtracting there must be that side. So if this was cos b, I would be minus b squared. If this was cos c, they were minus. Now I have to divide this whole thing by 2bc. And it's always divided by these two letters that are there. The same way like those two letters are in here, right? Okay? BC, when you do A, AB, when you find C. It's the same type of scenario. So cos A is going to be that B squared plus C squared minus A squared all over 2BC. This is the general form when you are having a scenario like that. No? A scenario where you have all the sides. Then you can find the cosine of that angle. But now remember, in order for you to find the angle, you must find the inverse cos of whatever your answer is after doing that. And here again, since we are dealing with radians, we have to make sure that our angle is in radian mode. If you are dealing with degrees, you must make sure that this is in degree mode. The angle that you are looking for. When you take inverse cos, inverse tan, this inverse, it allows us to find an angle. Because we are looking for an angle, we have to be specific in what we want the angles. If our problem is given to us in radians, then it would be best that we change this, our calculator mode, to be in radian or in degrees depending on the question. You understand? Does that make sense? There's another one. It's a sine rule. But it says the sine rule is quite easy for people to remember. I'm not going to go ahead and prove it, but there are some videos that I have done on trigonometry that you can have a look on. It was, I think I even labeled it the sine rule. Okay, but since the sine rule is quite easy for people to remember, I'll just write it down anyway, so you can see the stuff that we are going to use with what is coming. Is that okay? So if this is the scenario for cos A, I can also then write the scenario for cos B. You get it? Little cos B? Don't get it. Cos B is going to be, the B square will be subtracted. So A squared plus C squared over 2AC. Cos C will be, C squared will be subtracted. A squared plus B squared over 2AB. There you go.
So what was the very first one? Not that one, the other one.